Keep here.
Yeah,
Keep
yeah,
here.
keep both the files over here. Okay, done. Let's come to your edge node, and today we'll try to see the three different types of joints which Hives provides to us. Okay, so we'll try to see step by step what are the three types of joints which Hives provide to us. So the first is map join. Okay, as the name itself suggests, map join. So let's see the theory first. A little theory. So map side join is a process where joins between two tables are performed in the map phase, okay, without the involvement of reduce phase. Okay, so if you see now, like in the previous sessions, like yesterday, we were trying to join, okay, we were trying to join some tables, two or more than two tables. So when we were executing those joins, what was happening is like a map reduce job was getting executed. Okay, so first the mapper phase gets involved, and then the reducer phase gets involved. So whenever the reducer phase gets involved, there are a lot of network shuffling which happens over the network, and which causes the data to move from here and there, and which degrades the performance. So to increase the performance, one of the joins which was suggested was map side joins. Okay, so what it tells us, we can implement this map side join at map phase without involvement of the reducer phase. That is the first thing. Okay, what the second thing says is, map side joins allows a table to get loaded into memory, ensuring a very fast join operation. Okay, performing entirely within a mapper, and that too without having to use both mapper and pen. Same thing. The only addition to is like it is just allowing a table to load data into memory just for a faster operation. Okay, so just remember, whenever we are performing the map side joins, okay, so always your mapper phase gets involved, the reducers are not involving, and the data is loaded into memory for faster operations. Okay, so this is what we need to remember. Okay, so we'll try to see how the map joins will behave. Okay, map search joins. Okay, I've already shared the data set, and you have already downloaded and uploaded that data set into Edge node, correct?
Correct.
Now what we need to do is we need to create a table. Okay, so you can copy these create table statements, because now we are good with all like table creation, etc, etc. Just write map side join. So we just need to understand what are the map side concepts. No, it's given in the PDF itself. You can copy those, because the table name and the data set name would be appropriate. Yeah, so that is the first table. Copy that first table. Yeah, and we'll just verify when you paste that in the notepad. Okay, so we are creating the first table. So create table, if not exists, table name. Okay, that is data set 1. So id of integer, first name or string, row format delimited, fields terminated by, and table properties header equals to 1. Yeah, execute this table in your Hive terminal. So we are creating one table in your Hive. No, not here. So we'll have to go to the Hive terminal, right, Punaranjan?
Sorry.
Yeah. Okay. So this is the first table which we are trying to create. Okay. Meanwhile, can you see the second table? Copy the second table syntax. Okay. So we are creating two tables. So this is your data set 2. No.
Correct.
First. Okay. Execute it. No issues. Try to copy to your notepad also because you'll be sharing the syntaxes, right? Okay. So what we have done is we have created two tables on the basis of the data set which was given to us. Correct?
Yes, right.
Yeah. Now can we load the data into these two tables? Load data local in path. Yeah. You just need to change your and it's dataset1.csv, not txt. Just remember that. Yeah. Okay. Load the data into these two tables. Copy both the statement. You just need to hit enter. That's it. One after the other. Okay. Both the things are done, right? Okay. Now what we have done is we have created two tables, dataset 1 and dataset 2. Okay. We have loaded the data into these tables. Now we'll try to perform some joins. Okay. Is it possible, can you just do a right click and top of the screen? Can you open new session? Duplicate this session. Okay, so try to log in as, and open in spite of opening a Hive terminal, we can open, because we just wanted to test the performance. Okay, so can you open one more Hive terminal? That is fine, even that is issue. That's not an issue. No, not a year only. Close this. Yeah, just write Hive. Yeah, and once this session opens, use our database.
Okay.
What we will try to do is we'll just try to test the performance difference between the normal joins and the map joins and so on. There will be not much performance measure like metric, but at least there will be a small difference which we'll try to see because the data is not so huge. First thing. Second thing, it's a single node cluster. Okay. Okay. So can we come to the use Hive database? Yeah. Use it. Okay. Now let's come to the notepad. So third terminal we will execute the map side joins, and the second terminal I'll tell you, don't worry about that, I'll manage those terminals. Now whenever we are applying the map side joins, what we need to remember is we need to set one property. Okay, remember how we have set certain properties for dynamic property. Okay, dynamic property, and before this for bucketing we have set that hive.enforce.bucketing equals to true. And when we were
Yes.
applying the dynamic partitions, we had set the partition that set dynamic partition equals to mode equals to true, right? So the same way we'll try to apply some properties so that it will allow us to perform a map side join. Okay, and what is that property? Set hive dot, can you write it, can you go to the bottom? Yeah, so the property is set hive dot auto dot convert dot join equal to true. Join. equal to true. Whenever you want to apply a map side join, this property needs to be set. Got it? Set hive dot auto dot convert dot join equals to true. Can you copy this and execute in the third terminal? Yeah. Yes. Okay. Now we'll try to write a join, and there is a small syntax change in the map side joins if you want to write. Okay. So, like how we mentioned that flower brace is a multi-line comment in the Java code or any of the programming knowledge, so same way we just need to write extra one thing. Okay. Now let's try to join these two tables. Okay, data set 1 and data set 2 tables. Okay. So okay, the way of can we write select? So it's just a small change. Understand the small change. Forward slash. No. There is a small change. Forward slash asterisk. Okay, space, sorry, plus. After asterisk we need to give plus, and in the capital can we write map join, space map join. Continuous. Okay, and in the parenthesis can you write the second table? Okay, and after that, yeah, space asterisk and backward slash, sorry, forward slash, my mistake. Now let's understand what is the syntax. Now what I'm trying to do is I'm trying to write a select clause. Okay, and in the flower braces with the forward slash I'm just trying to say it's a map join, and the table which I'm trying to specify is the data set 2. Okay, so it's always preferred the table which has the lesser data. Okay, that needs to be the second table. Okay, that's what the scenario says to us is. Okay, so if you go to the PDF, the syntax will be the same. Can we go to the PDF and just verify whether the syntax is written is correct? So we have loaded the data, right? And we have set the property, right? And can we see the map join? There's a first, by specifying the keyword forward slash plus map join B in the join statement. Correct? We have done that, right?
Yes.
Okay. So that's it. So I think we are good. So can we go ahead and write the syntaxes? Okay. So can you just describe the first table? We'll just try to pick few columns. We'll not to take all the columns. We'll just take one or two columns from here. And okay, so first name, last name. Yeah, cool. And can you share the data set too? What is the joining column? Here we have ID. What is there? Okay, here also we have ID. Okay, and first name, last name also there, and first name, last name also there. Okay, we can use only these two columns and play with it. Okay, let's come to the notepad.
Yes. From here we'll take email.
We can take any column. It's our call. The joining column should be ID. Apart from that, you can take any column.
Mm-hmm.
As of now, we don't have a concrete requirement. Like the control is in our hands. I can take anything, right?
Yes.
Okay. Now, can you just give a space? Okay, we'll try to take data. So let's we'll try to alias data set 1 as a D1. So can we write D1 dot first name, first underscore name, yeah, comma D1 underscore ID. Okay, then should we take D2 ID also? Because any of the joining condition will be there. So, okay, so we just need to say, and so you can take any column if of your choice from your D2. Yeah, even email is fine, no issues. So these three columns are from my first table. Yeah, remove the comma from the beginning.
I've taken like this D1 from D1 ID email from D2 first name, last name.
No issues, no issues. Anything is fine. We just need to verify the things are working or not. Nothing else. Okay. Yeah. From 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 the table. So the table name is second table is dataset one.
No, second table is data set 2.
Means okay. Means like the table which we are missing.
Okay.
We need sorry. We just need to mention the first table dataset one and alias is as D1 because we have used right D1. Join dataset to D2 and the joining condition on D1.id equals to D2.id. And after writing the joining conditions, just specify limit 5 records. We don't want to see the entire data sets because the data set is huge. Okay. So what is the see all the syntaxes are same like how we have written the joins yesterday. Only the difference is we are adding that for the flower braces and the map join. That is the only addition. And the second addition is hive.auto.convert.join equal to 3. Correct? Yes,
So
no?
it looks like hints in Oracle.
It looks like
Hints in
hints.
Oracle
Yeah,
hints.
perfect. Yeah, hints. Hints, yeah, that's right. Okay, can we execute this in the third terminal?
Yes, I hear one question.
Yeah,
So we are specifying that map join data set
execute it.
to the table name too, right? So why? How we have to pick that
So the
second
table
table?
which is having the lesser data, we need to pick that table as a data set means in the map join.
Lesser data means the count.
Yeah, the count.
Okay, fine.
And can you copy the same statement? Yeah, write that. We want to we want to see the time difference. Can you copy the select statement and remove that map join and execute this? Can you copy the same statement and paste in the notepad at the below and just remove that map join and execute it so that we'll understand the time difference. Remove it. Yeah, execute this in the second terminal. So the second terminal will be without setting the property of map join. Okay, we'll try to see what is the difference. Hit this. Yeah. So in the second terminal, it's a normal join we are performing, and in the third session, we are trying to see the map join. Let's see the difference. Are we able to see any performance difference between these two type of joins?
So if the map then enhances the performance,
Yeah.
that means in the industry people do not use this normal join.
See, it enhances the performance definitely. So it depends like use cases. Like if you want to go for map joins, you can go for map joins also. There are certain like after map join you'll get bucket join. After bucket join you'll get sort merge bucket join, which is like a better join because it sorts the data and everything. Like we'll try to see that step by step. I hope there should be a time difference because we are having just a small data. Okay, see, it has taken like almost 129 minutes. sorry, 129.275 seconds. So which is this terminal? Is this the third terminal or fourth terminal? Second terminal.
Third terminal. Map.
It has taken a lot of time. Okay, can you come to your second session? So this one is giving a lower performance, 120.
No, here where it is written that 120.
At the second last line.
Okay.
But if you see cumulative CPU is 5.04 seconds over here, and can you go to the third terminal?
That is also 5 point something.
5.44. Okay, it's consuming more time. Ideally, like, it consumes less time. That's what I have observed. Can you go to your PDF, because I think I have removed some screenshots. Let's just see over there. Do we have some screenshot validations? Yeah, can you see that? So then that is fine, but okay, I have not taken like both the
Screenshots.
yeah. But I think I have experienced that. No issues. We'll try to see that. But again, let's come back. There should be a difference, because as this is a single node cluster and the data site is not so huge, we are not able to see the. Or else, what we can do is we can open the beeline terminal also. Can you close your third terminal? Yeah. Can you just press Ctrl C? Yeah. Can you write beeline? No, B-double-E. Yeah. And can you come to your notepad? Meanwhile, hit enter. Yeah. And can you write one syntax till the time it is opening? So, exclamation mark, connect, space, JDBC, colon, Hive 2, colon, / twice, localhost, colon, 10,000, space, Cloudera, space, Cloudera. Then we need to write org.apache space org.apache.hive .jdbc, initial caps Hive, dot, I did not say any space, dot, H capital, Hive, D capital, driver. Yeah, Hive driver. Yeah. Copy this command and execute it. So your beeline terminal should get open until unless the syntax is not correct. Paste it. Yeah, hit enter. Okay, can you use the Hive database? Can you show tables? Yeah, we can see the tables. Okay. Can you execute your map join statement again over here? Map site, map join. Yeah. Execute this. You'll have to before that you'll have to set the property because the session is open new. Yeah, we need to set that property because the session is new. Yeah, hit enter. Cool. Now execute your map join. Let's see in the beeline, because beeline what it does is the connection happens through thrift server via client, so definitely it should give a good performance as compared to your Hive terminal. It will take some time. Okay, so it will take some time to evaluate. So till the time we'll try to see what are the PDFs, so any things which are given in the, I think that's the only thing, right? So the second is map join, bucket map join. Okay, so the number of reducers will be set to 0 automatically. Can we see that in the second screen? Can you just verify where is that number of reducers? 0? No, that is not there. Above that, to the right hand side, yeah, number of reducers are set to 0. So if you see that in this map join, the reducers are not being used. Okay, so the time consumed is 120.06 seconds. Okay, that's where it has been taken. Now let's try to see what is the time consumed by R. It's still in the execution phase. Okay, so it will take a little time.
If we are using any application function in our join, still it will not use any reducer.
We are still what? Can you please come back?
If there is an aggregation function in our joining case, in our select query, so then still it will not use the reducer.
Then it should use your reducer, because whenever your aggregations get involved, okay, at that moment of time your reducers comes into picture. So at that moment of time you'll have to maybe play with your joins. First you'll have to do the aggregation and then maybe then do a joining kind of thing. If that is not able to perform, then you'll have to go with the normal join. Okay, if you see now here we are just getting the data in 84.59 seconds. Okay, and there we were getting the data into 120 something. Okay, so there is a small difference, but again this we are trying to use the beeline, and definitely beeline is faster than to your normal Hive terminal.
So here it is showing number of reducers is 0.
Okay,
Here I think here also showing 0.
yeah. There will be 0. There won't be number of reducers. So that's where because all the things are calculated at your map phase only. Got it?
Okay.
Okay, so let's see what is the second type of join which Hive provides to us is bucket map join. Can you just go to the...
But it came in a tabular form.
Yeah, it will always give in a tabular format. Remember the first session which I have already told you? So the beeline will always give you the data in a tabular format.
So which is better? Always we have to use that beeline or we have to use the Hive terminal?
It's your call. It's your call. You can use anything, but in production we always in projects we always use beeline.
So there is no much difference in between these two. Only the tabular form.
No, there is a difference, because if you see, this beeline uses a thrift server. Remember the Hive architecture?
Yes.
I showed you the client can be connected in 3 ways. The first one was Hive CLI, correct? The second is beeline, and the third is, what is the third one? Does anyone remember that?
Web UI.
Right. What was that?
Web UI.
Web UI, correct. And what was that web UI? HUE. Yeah, correct. Okay. So the beeline always gives you a faster connectivity because the client sessions are established via a thrift server. Okay, so it gives a better connection and better network speed as compared to your normal Hive CLI. That is what we need to remember. Okay, let's see the second type of join. What is the second type of join? Bucket map join. Let's understand the theoretical, okay, and then we'll go to practical. As the name itself suggests, bucket, okay, which means that the table needs to be created with a bucket. Simple. So let's understand theory. So the constraint for performing bucket map join is if tables being joined are bucketed on the join columns and the number of buckets in one table is a multiple of number of buckets on the other table, the bucket can be joined with each other. Okay, so I'll explain you that. Okay, so to create bucketing we need to have bucketed tables. Okay, that is okay, cool. And I think we need to set one property, that set hive.enforce.bucketing equal to true. There should be one property which we need to apply. Yeah, so bucket map join equal to. Okay, got it, cool. So let's come to the theory. Can you scroll a little up? I'll explain those 2-3 points which are able to be okay. So the first thing is, for the bucket map join we always need to remember is the table should be bucketed. Okay, what is the first condition? The first condition is the table should be bucketed, and the second condition is if the tables are being joined on the join columns, okay, and the number of buckets, okay, so I have already read that. So when we are joining two tables, okay, and those two tables should be bucketed and on the same column. Okay, the two tables should be bucketed, first thing, and it should be on the means mostly on the same column. Means like we all know what is the joining column. It should be on the same data value column. Okay, and the third important point is the first table should be multiple of the second table. Now what is this? Okay, let's understand the first table. Let's table A is having two buckets. So the table B either should have 4 buckets or 6 buckets. Sorry, in the multiple of 2. So 2 buckets, 4 buckets, 6 buckets, 8 buckets, and so on. Okay, are we able to understand that? So that is what it is telling us. So in the other table, the buckets can be joined with each table because it is a multiple of number of buckets. So let's understand, if the table A is having 3 buckets, so the table B what should have? It should have either 3 buckets, or either it should have 6 buckets, or either it should have 9 buckets, or either it should have 12 buckets, and so on. Are we understanding these 3 points?
Yes.
Okay, so the table should be bucketed, the joining column should be mostly the common column, and the third is like the
But
bucketed.
why is it like this? Means the number of buckets should be multiple of number of the buckets in the table.
That's how it has been designed. Even I have not able to identify, because when we try to join on the same bucket, it does not give you the optimal performance. We try to test that, so the performance is not being it gives like the same performance like a normal Hive CLI. But when we try to give the multiples of Hive buckets, then it tries to give the optimized performance. That's what we have observed. Okay, so let's try to create I think we already have one bucket let's try to create now bucketed table. So bucket map join, it's not a bucket side join, it's a bucket map join, right? Yeah, can you copy the first table and second table create statement? So we'll just change here and there. Yeah, so let's see what are the changes we need to do? So create table if not exists. Can you change the table name? So data set 1, let's say let it be underscore BKT. So we will understand that it's a bucketed table, correct? Okay, the column names should be same, the row format delimited and the fields terminated by should be same. Okay, and we need to write one thing. What is that one thing? Not there, after the closing parenthesis. Yeah, what we need to write?
Let's bucket.
Clustered by. Okay, so what we need to write? We need to write clustered by. Simple. Okay, and which we had ID first name. Let's take first name. Can we take first underscore name? Yeah, we'll try to take that as a bucket. And how many buckets? Remove that space. No need to give the data type because it's already there, right? For static partition, we try to give.
Okay.
Yeah, clustered by column name and space. How many buckets? Let's go with 4 buckets, into 4 buckets. Okay, so this is how your syntax would be. So create table and the table name, the column names, and the clustered by the column into 4 buckets, then row format delimited and the fields terminated and the table properties. Yeah, looks good to me. Can you execute this? It is giving some error. So clustered by, it is telling some spelling error. Yes, there is a typo error. So clustered by, CLUSTERED. Can you remove that extra D? Yeah, yeah. And I think wait, go back. Clustered, yeah, correct. That is correct. Spelling is correct. Can you execute this? Now it should, yeah, the table is created. Okay, so similarly, can you create the second table with 8 buckets in the multiple of holes we are trying to go, and we'll try to test the performance in the third type of join by creating the same buckets. We'll try to test that. So data set 2, yeah, and just trying to change the 4 buckets to 8 buckets.
The column name should be different.
Yeah, cool. Yeah, looks good.
Okay.
Yeah, looks good. Yeah, the 2 tables are done. Okay, we need to set one property now. What is that property? Set Hive dot. Yeah, I remember that. I got it. You can copy it. No issues. Hive dot optimize dot bucket map join. Just we need to remember that. So for the map join, we need to remember hive dot auto dot convert dot join equals to true, and here we need to write hive dot optimize dot bucket map join equal to true. Yeah, execute this. Execute this in your B line. So we'll try to execute. Yeah, we'll try to execute. Clear of the screen. Yeah. No rows. Yeah. Now let's try to create your
Join circle.
same thing. The only difference, you can copy that. Copy that and paste it. Just change the table names. I think the syntax will be same only, right? There should not be bucket map. Yeah, correct. There should not be bucket map. So select the dataset 2 underscore buckets. The column names are the same. Dataset 2 underscore 2 bucket. Okay, looks good to me. And yeah. And so for bucket map, yeah, that is correct. Cool. Yeah, can you just verify? Go to the PDF. So as far as I am able to recall this, we don't specify. We just specify the same map join. A little down. Yeah, the syntax is correct. Can we execute this? So now we are applying a bucket map join. So there is no keyword like bucket map join. So the same keyword we need to use map join. Okay. So execute this over here. And can you execute the same statement in the Hive terminal without that map join? No. First change the syntax. Yeah. Yeah. Now execute this in your Hive terminal. Let it get executed.
By seeing this syntax,
Uh-huh.
how do you know whether it is a bucket map join or with a
By
map join?
no. By looking at the syntax, you will not identify that whether it's like a map join or a bucket map join. Okay. You will have to specify that property. Remember, by specifying before this join, whenever you are applying this join, before that join, you need to instruct your Hive whether you want to go with your map join or you want to go with your bucket map join.
Okay,
By
yes.
looking at the syntax, you'll not be able to identify whether it's a. But again, if you show the table, the second way of checking the thing is you can go to your table syntax, and if the table is bucketed, so definitely there will be a bucket map join. These are the two ways.
Okay.
We are not having the data. It should not be the case. Oh, we did not loaded the data. Remember, these are the new tables which we have created, right? Can you load the data? Yeah, anywhere is fine. Execute it. Okay. Now execute the statements again. So in the beeline terminal, execute. No. It will not do that. Just copy paste from here because that will be like single line. Yeah. So execute this in your beeline. Yeah, and the second one in the normal terminal, Hive terminal. So we'll try to observe what is the time difference. it is consuming time. Let it consume. No issues in that. As this is a single load machine, and hence it will consume time, and it purely depends on the RAM of our local laptop as well. That is not up to the mark, so hence it is consuming time. Let it take those time. Not an issue. Can we see the data in Hive terminal? Okay, so it is still it has started your map reduce job. So it is taking like 155.943 something. Okay, so there is like small time difference between these two. So we are able to see a small difference when we are trying to execute the bucket map join and the normal join. Okay. So these couple of joins try to give you a little performance boost. Okay, now it's a small data and the cluster is not so productionized, hence we are not able to see a good time difference or performance difference, but in productions you will try to see a good difference. Got it? So what is the difference between map side join and bucket map join?
Yeah. The number of buckets should be always multiple of...
Always multiple, yes. The table should be bucketed and the table should be multiple of buckets from the first table. And one property we need to set optimize.bucketMap join equal to true. As compared to your map side join, we just need to say auto.set hive.auto.convert.join equals to true, and there only the mapper phase will get executed, no reducers will be applied. Okay. That's it. So these are the two types of joins, and let's see the third join, that is sort merge bucket join, SMP join, which we call. Now what are these? Let's understand theoretically. Now if the tables being joined are sorted and bucketed on the join columns and the same number of buckets, okay, now here the data should be sorted, okay, as the name itself suggests, sort. Okay, so the data should be sorted. The joining column should be on the same key column. Okay, and the third important thing is the two tables should have the same number of buckets. In the earlier scenario it was multiple of buckets, right?
Yes.
But here we should have the same number of buckets. Can you see the first line ending and have the same number of buckets? Okay, so if you have the same number of buckets, then only we'll be able to apply the sort merge bucket join. Okay, and also the data should be sorted. Got it? Understood the couple of things? So the data should be sorted, first thing. The joining key of the two bucketed columns should be the same. And the third thing is, what is the third thing?
Number of buckets will be same.
Yes. Okay. And can you copy these three set statement, because even I don't remember these set statements. So I always copy paste, yeah, because they are like hard to remember. Okay, so now what we'll have to do is, remember, so we'll have to create now one, so dataset 1 bucketed is having 4 buckets, right?
Yes.
And dataset 2 bucket is having 8 buckets, right?
Yes.
Okay, so that is not the correct scenario, right?
No.
It always expect the same buckets, right?
Right.
So what we can do is we can copy the second table. Yeah, we can copy that second table, and let's create one more table out of it, and just change the table names. Yeah, something like bucket, after bucket, anything like underscore smb, sort merge bucket, just for remembering the table name. Okay, and the table should be same bucket. Just change it to 4 buckets. Yeah, can we execute this? So now what we are trying to do is we are trying to first table is already created, right, with the 4 buckets, data set 1, right?
Yes. Yes.
Now we are trying to create the second table with same number of buckets. Okay, now can we load the data? No, don't go with this method. The table is already data is already in the first table, right?
Yes.
We can use the insert command, right?
Hmm.
Can we write that command? Insert override. Insert override. So the first table name is dataset 1 underscore bucket, right?
No, data set 2.
No, dataset 2 is like we have already created a new table for this, right?
Yes.
Yeah. So the first table is dataset 1, right? Can
Yes,
you go a
correct.
little up? Yeah. Yeah. This is the table, right?
Yes.
Okay.
No, from where you want to take the data? See, now I created this table. So you are telling that I have to write a query to insert the data from the existing table to this table, right?
No, we'll try to reload both the tables. We'll try to reload the first table and we'll try to reload the second table. The first table is not sorted, right?
Okay.
The
So
data
sorting
is
the
there
data.
in the
Okay.
first table, but the data is not sorted, right?
Not sorted.
We need to sort the data, right?
Okay.
For
That
that,
means
what we will
before
do, remember in the map side join, we have used one table.
map side. Okay.
From that table, we will pick the data and we will load into the dataset 1 underscore bucket table.
Okay. This is the map side.
No, this is not the map side. It
The
is
map side.
without underscore BKT.
Yeah. This is the map side.
So from this table, we will try to load the data into the underscore bucket table.
Underscore bucket. SMB or only bucket. Underscore bucket.
See, we need to load the data in both the tables, right?
Yes.
So we need to load the data into 2 tables. From first table to the first table, second table to the second table, because the structure is different.
Okay.
You just write this statements, you'll get that.
Okay. Okay.
So can you
Set
just
the
write
word.
insert override table? I'll tell you, I remember the table names. I'll remember the table name. I know the table names. Insert override table name. Sorry, table. No, insert override table as a keyword. Yeah. So we are trying to load the data into dataset 1 underscore bucket. Yeah. In this table, we are trying to load the data from the space. Select star from dataset 1. Select star from dataset 1 and sort by first name. We are trying to do sorting. First underscore name. So what we are trying to do is we are trying to overwrite the dataset 1 underscore bucket table because the data is not sorted, right?
Correct.
Are you able to understand now?
Yes, understood.
Yeah. Can you execute this statement now? Yeah. Can you go back and let's create one more statement for the second table? Yeah. Insert override table. So dataset 2 underscore PKT underscore SMB. Yeah, copy that table name. Yeah. Now we are trying to load the data into this table, correct? From where we are trying to load? From the data set 2 and sort by F. That's it. Execute this in your B line. So we'll try to utilize both the terminals. Yeah. So got the scenario. Now what we are trying to do is we have created 2 tables. So the first table was already created with 4 buckets, but the second table was created with 8 buckets. So we wanted the same bucket, so we created a new bucket table, right? And then we are trying to reload the data into these 2 tables. Or else what you can do is you can just but with the load command, I am not sure whether we will be able to write the sort command or order by command. So hence we need to load the data into an intermediary table.
Okay.
Can we see the data is being loaded or not? Okay, so it is applying the map join because the data is being taken from first table and loaded into the second table.
We'll write that syntax here for that join.
Yeah, we can write the statement. Yeah, can you prepare that statement? Copy that statement. Yeah, same thing. We just need to change the table names. Properties. Yeah, properties. Before executing the queries, we'll try to set those properties. Yeah. So the condition is selects map join the second table. So the second table, we need to change the second table name. Can you change the second table name? Then we are trying to use the column names. Okay, that is fine. From table 1. So change the table 1. No, table 1 is correct. Change the second table name. So table 1 name, table second name. Okay.
Yes, correct.
Yeah, can you go to B line? We can execute that at least. Okay, so even it is executing. Okay, it's consumed because the data is like huge, and let's let it take time. So we just need to execute and see whether the sort merge bucket joins are getting applied and what is the time consumption that is being taken. What you can do is just normal thing. You can apply that on the Hive terminal. Remove that, apply that. So that we'll try, let it get executed there, and once we finish that, we'll try to see the it get executed. Let's come to your beeline terminal. Before that, we'll need to set properties, right? So can you set these 3 properties? So hive.bucket, let me just see the bucketized input, bucket map. So I always try to remember this, but somehow I do not remember this. Okay, that is fine. Now let's try to let's hit this. So we are applying the same type of means the syntax while writing the joins is the same only. The only thing is the types of joins are getting changed. So in the map side join, what is the thing? So no reducers are being applied. Okay. Then in the second phase, what is the second phase? Bucket map join. So in the bucket map join, what needs to be taken care? The table should be bucketed and it should be in the multiple of first bucket. And in the third thing is that is nothing but your sort merge bucket. The data should be sorted, okay, and the table should have the same number of buckets. So all these pointers you need to remember, okay, whenever we are trying to execute, means whatever the type of join which we are trying to execute.
So that means the two tables should have the sorted format of data, sorted form of data. Before applying
Which two
this one,
tables?
I mean that last join, that short merge step, short merge.
Yeah, yeah. It should means it should contain that. What you can do is you can pick the data, you can load the data into an intermediary table and load the data from that intermediary table to the bucketed table.
But in real scenario,
Mhm.
uh,
I have never used this bucket map join, sort merge bucket join. We have already means we normally go with normal joins only.
because that's why I'm thinking, because in the normal, I mean in the scenario, the industry,
Uh-huh.
there should not be two tables in sorted format.
Right, right, right. Because again, because the tables in the projects or the production, like they are huge, and
Yes.
again to consume the sorting, again it will take a lot of time.
Yeah, sorting is a huge performance impact. It will impact
Yes,
hugely.
yes, yes. I have never used in my project all these type of joins. We because in normally when we load the data into the Hive table, generally we just do the normal joins and we move ahead. So
So here is the output 109, here 107.
okay, so here it is taking a less time. Okay, that is not an issue. So it's like
Maybe that due to data, yes, less number of data is there.
yeah, yeah, because that is it should not be a concern. But it's like a data size, and the second is like the cluster size. These are the two predominant factors to do these things. Okay, so these are the three type of joints which we wanted to see today. So let's stop it over here. So these are the three